Well, you can see the exponential curves of the shift on both the energy supply side, when you see, everything from wind to solar, but also the integrated solutions. And I think that's one of the challenges, that many of these exponential challenges and changes happens only if you aggregate it and view it from a different angle. So if you only look at the isolated technologies, you don't see the full picture. So when you look at the integration now in buildings, for instance, you see an exponential uptake of new smart building solutions. And that brings back the challenge for a sector that is used to sort of deliver energy. But now those who are being delivered to can start finding their own solutions.
If we look how digital transformation affects the energy system, we can categorize it in the effects on the network level in four different areas. Four different areas which each area needs different strategic decisions and strategic reflections. The first area is reduction of cost. We see that right now that key technologies such as solar power, utility-based solar, battery cost are decreasing. But it's not only that they are decreasing in prices, because that's quite normal, but it's the pace on which these costs are being reduced, that with an exponential pace, that is really the challenge for the market. Because if we're thinking about price reductions, that is 30 to 70% over a 5-year period, that's quite dramatic. For the energy market, the drop in prices changing the sourcing strategy and the energy mix, as well as we must start to recognize other alternatives such as local energy systems and prosumers into our electrical grids. The second area where digital transformation affects the energy system is the efficiency on the grid. We can see that normally ICT and technology development increases efficiency in most industry. This is also a fact when it comes to energy, the energy systems and the energy grids. We can have other load management, we can have other distribution management systems, we can have demand response technologies. All of these opens up to better efficiency and smarter grids. A dilemma is that internet is opening up the energy grid to the internet, which means that we also must recognize the risks of cybersecurity into the energy systems. The third area is new market opportunities. This is perhaps the biggest and most interesting area for energy companies, as new technologies and digital transformations integrate ICT with the energy system. This opens up for totally new solutions where the combination of energy system and digital transformation. We see that tools and communication technologies such as smart meters, IoT, cloud computing, together with the areas where you're going to be applied in smart homes, Industry 4.0, electrical vehicles and so forth, is really merging and including the energy systems into other business areas. This means that energy companies must and should recognize what role they should play in other systems. And first of all, we need to understand that energy companies goes from just being a producer to being an enabler of new market opportunities and new business models. The fourth area is that energy companies and energy systems are coexisting with other business models. And here is going to be a lot of new ideas and scopes over the next coming years. And what role the energy company will play in different markets is really up to the energy company to decide and reflect upon. For example, if we take electrical vehicles, and it's a strategic decisions that must be made, and that also will differ if the electrical vehicle market stands for 1% of the automotive market, or if the electrical vehicles will stand for 45% of the automotive market. Those strategic reflections and strategic decisions are decisions that the energy companies must make based on the digital transformation.
I think there are three services that the data center can provide in the electrical grid or in the energy system. Frequency, containment and restoration, reserve capacity when there are peak loads, and again this problem of mitigating problems with bottlenecks. In addition to this, the data center can use its resources on the cooling side for the cooling and heating market. So we're working on solutions to recover the heat that, as you all know, the server is doing very little mechanical work. So all the energy that comes into the server is actually more or less transformed into heat.